Hey folks, I'm Jen Foxbot, and welcome to part 3 of this series on logic gates. Oh, I see. My dog wants to come join us. Okay, you just opened the door, that's funny. Anyway, so part 3 on logic gates, yeah, woo! Marley, what do you have to say about it? He's just smiling at me, that's fine. I guess he's learning today too. Okay, so, in this part we are going to talk about, how we build an adder using logic gates. Like if we had the logic gate chips in front of us, how would we wire them up to basically do binary addition for us? At the foundation of it, that's what computers do. They do mathematics to figure out how to store and transfer information. And that's why we program them. We tell them how to use different instructions so that we get what we want to do. So yeah, okay. The other thing I was going to say is that addition and subtraction is really the foundation for all computing. Once you have addition and subtraction, you can do more complicated mathematics like multiplication, division, exponents, etc. So the first thing that you need to do to invent a computer is first create the universe, or whatever, as they say. But yeah, so creating an adder out of logic gates is your first step to making a full-fledged computer. I don't recommend building one out of logic gates, though, because it would take a lot of logic gates and a lot of table space. I wonder how big it would be. Interesting. Anyway, okay, so let's really quickly review 3-digit binary addition. It's a little different than base 10 addition, but it does actually follow the same rules. So, for example, let's say that we have 0, 1, 1 plus 0, 1, 0. And so we get 1 plus 0 is 1, 1 plus 1 is, oh no, we only have 2 digits, what do we do? Well, when we have 9 plus 1, we would write a 0 and we carry the 1. Same thing here, we just have 2 digits, so it happens a little faster, which is why our binary numbers need to be really long in general. And then 0 plus 0 is 0, but we have our 1 carried forward from the previous digit, so then we bring that down. And so that is our answer. Okay, so now that we know that, we can build a logic gate adder to basically do the heavy lifting for us. It's somewhat trivial when you have a 3-digit binary number, but most, at least, well, as far as I know, most computers use 8-digit binary numbers to do most of their computations. And so when you have 8-digit binary numbers, it's a lot more efficient and a lot more reliable to have a machine do it, because humans get tired, we make mistakes, machines don't, unless they're broken. So, how do we start? Well, first of all, I'm going to introduce a new logic gate that I haven't really talked about before. It's called the XOR gate, which stands for exclusive OR. You draw it like this. Oops. There we go. Okay, so it's got a little pointy head. That's XOR. So that means exclusive OR is the output of this logic gate is 1 if and only if the 2 inputs are different. So what does that look like? You have A, B, and out. So if A is 0, B is 0, out is 0, they're the same. If A is 1, B is 0, out is 1. If A is 0 and B is 1, then the output, they're different, so the output is 1. And if they're both 1, then the output is 0. So this is similar to the OR gate, but the OR gate is going to give you a 1 here. So for an OR gate, you would say the output is 1 if either of the inputs are 1. The exclusive OR gate, that's where you have the if and only if statement, which means that that's what our truth table looks like. So this is important because if you were paying attention to the binary addition, you'll notice, ooh, that's pretty much the same rules that we get for binary addition, right? 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, 1 plus 1 is 0, and then we have that kind of like footnote where it's like, hey, psst, carry the 1 over. So this is the first piece of the puzzle. The next piece of the puzzle is to say, okay, how do we carry information from the past into the future, or from one digit to the next digit? I'm going to erase this to give me some more room. So I'm going to write our first two binary numbers that we use. So that was 0, 1, 1 and 0, 1, 0. I picked those numbers for a reason, which you'll probably see in a second. So the way to set up our calculator is that we want to divide this number into columns of digits, and the first two digits are inputs to our first XOR gate. So we get 1 and 0. So the output of this gate is going to be 1. Huzzah! That's our first digit. Woo! Done, right? Well, no. If we were only doing single-digit binary addition, no problem. That's all we would need. But since we're smart and we want to do more complicated calculations, we're going to need a little bit more logic gates to help us out here. So the first thing that we need to do is pass along information to the next set of digits. Because if this was a 1, we would get a 0 here, but we would have to carry that information to the next column. So what I'm going to do, what logic gate do you think we can do to help us out with that? Okay, I think that's enough time. So we can use an AND gate, because an AND gate will tell us if the two inputs are the same. At least if the two inputs are both 1, then your output is 1, and that's exactly what we want. Because if our two inputs are 1, we need to tell the next OR gate, psst, by the way, there's an extra 1 in here. So I'm going to draw an AND gate. And so for this one, our output is going to be 0. I'm going to write that right there. And now we can bring in our second XOR gate for the second row of digits. So we have, and there's this little, that's part of the OR gate. We have that little line. And then our next set of digits is a 1 and a 1. And so the output of this is 1. And now what we do is we combine these two into another XOR gate to get our second digit output, which is going to be 1. Boop. Okay. So, yes. Okay. Wait. Yeah. No. 1 and 1. Oh, that was silly. I hope you all caught that. I love when I was in class and my professors would make a mistake and they're just going and I'm like, oh wait, and then they realize it and they're like, yes, I caught that. I know what's going on. So if you caught my mistake, that's awesome because it means that you know what is happening and that's super important. So this actually is going to be 0, and then that 0 plus 0 in our XOR gate is going to be 0. Okay. Everyone makes mistakes. It's just important to acknowledge it and be like, okay, moving on. Okay, so that's our second digit. That's why checking your work is good. So, second digit, now we need to pass along information from the first digit, the second set of digits, to the third set of digits, this column. So for that same process, we need another AND gate. So in this case, the two digits are the same. And so the output of our AND gate is going to be a 1. And so we can start drawing our third XOR gate, or 0 and 0. This is going to be 0. But wait! Now we're dealing with 2 digits worth of past information that we have to pass along to this. Because say, for example, these were the same. You'd have to carry the 1. And then you'd have to carry another 1 here. So you have to keep track of all of the addition that you've done so far to make sure that your final digit is getting all of that information at once. So we actually need to add another AND gate right here. And I didn't leave myself a lot of space, so I'm going to redraw this. Okay. And here. Also, by the way, that little like bump in the line, hopefully y'all can see that it's getting a little tight in there. That just means it doesn't connect there. Okay, so then this output, you could probably guess, is going to be 0. Okay, so now we can basically just combine all of this information with a couple more XOR gates to get our final result. Yay! So these two feed into each other. And then 1 and 0 is going to be 1. And then these two feed into each other. And our final result, 0 and 1, is 1. Woo! So then we read it from bottom to top, 1, 0, 1. Boom! Same result, after I fixed my little mistake in there. Okay, cool. So this might seem a little messy. I have a better picture here, which I'll show up close. So, we have the top digit, the top two, or the first two digits, or the first two? I guess, sure. The right-hand most digits, there we go into this box to give you the result. Then you have an AND gate that comes down to combine with the second digits to give you the result of the second column. And then 2 more adders. Oh, there's my dog. Someone's probably home. 2 more AND gates to combine or carry forward the information from the first 2 columns into the last column. So yeah, there you go. There is our 3-digit adder. Marley's saying hello to everyone in the house. Alright, so from there, you really just daisy chain this piece to add more digits for your adder. So this is the basic structure, and from there you can go all the way up to 8-digit adders, which is super cool. Subtraction is a little bit different. I think that once you get addition, you can figure that one out. So I challenge you to try and do that on your own. All right, so I'll leave it there for now. Thanks very much for watching. Please let me know if you have any questions, and if you end up figuring out the subtractor, you should definitely share it with everyone. All right, see you next time, folks. Have a wonderful day. Bye!